So we use electromagnetic induction in tons of different ways, more ways than I can possibly think to list right here, but I picked out a few of the most important ones to talk about here. um, as far as the AP Physics test, if you look back through some of them, um, you might run into a lot of questions about real world applications just to kind of check and make sure you know what's going on here. So the two most common applications of these things that we've been learning are the electric generator and the transformer, which I kind of mentioned a little bit in the first video. So first, electric generator, um, sometimes you might hear it called as a dynamo. I'm going to check my pronunciation on that, I think. Okay, wow. So yeah, I did double check. I couldn't find a dictionary entry for it for some reason. Oh no. Okay, so they just started shouting in my ear. Yeah, I just watched a 16-second video in which they said dynamo twice, and apparently I was correct. So it's a noisy little bugger for outdoor events that need electricity, or sometimes buildings will have them in the event that power would go out, or if you're into Fallout, in order to have any kind of electricity in your settlements, you have to make generators that are really, really annoying. My main base in Fallout is castle, so I have one of the rooms on the inner part of the castle dedicated to just generators to keep them out of the way from making noise and driving all of us that live there crazy. So, electric generators use the principle of electromagnetic induction and they convert mechanical energy. So, usually it'll be some kind of gas powered motor, which is why it's so loud, kind of like running your lawnmower to get electricity from it. They can take that and convert it into electrical energy. Um, so there's some kind of coil in the generator that rotates inside of a magnetic field. So the magnetic flux is constantly changing through the coil, which, as we just saw, induces an EMF and creates a current through that loop. Next way is the transformer. So transformer converts current of one voltage to current of another voltage. So a simple transformer is just going to be two coils that are wrapped around some kind of metallic core, iron apparently. Transformers rely on the property of mutual induction. So you can see the diagram here what that looks like. So the change in current in one coil induces an EMF in the other coil, and then that coil with the applied current. So this one here, these are really popular in microwaves. So this would be like where you plug your microwave into the wall, and then that would be your primary coil, and the coil with the induced EMF somewhere inside of your microwave would be the secondary coil. So the induced EMF here is related to the EMF in the primary coil, depending on the number of turns that each one has. So you can see here this one has only a few turns, this one has a bunch of turns, or just how many loops you could probably say instead of how many turns. So little relationship here, the EMF, the induced EMF in the secondary compared to the EMF in the primary is kind of a ratio of the number of turns that they have. So another example outside a power plant, you will have a step-up transformer whose primary coil has a fewer turns than its secondary coil. So it's meant to increase the voltage of the current that's transported along the power lines. And then just before it enters your house, you have a step-down transformer. So the secondary coil is going to have fewer turns than the primary, so it kind of undoes it. It reduces the voltage. The higher voltage on the power lines going all across the roads or wherever they need to go, allows a lot more electricity to be transported very quickly. But to your house, the appliances you have would absolutely burn up if they were exposed to that kind of stuff. So the lower voltage makes it a little safer to keep inside and work with indoors. So that is going to wrap up the second part of our magnetism unit, where we kind of put it all together into electromagnetic induction.